Today we are going to see resistances in series and parallel. First we will see how to arrive at a formula for calculating the resistances in series. Say you take three resistances, R1, R2 and R3, and you connect it to a battery of voltage V. These three are connected in series and the current flowing through is I, and you know the current, conventional current flows from positive to negative. So this potential V which is applied will get dropped in R1, R2 and R3. Say we will keep the potential drop as V1 across R1, V2 across R3 and V3 across R3. V1 across R1, V2 across R2, V3 across R3. Now since the potentials V1 and V2, V3 is equal to V, I say V is equal to V1 plus V2 plus V3, and the common current is I divide it, V by I is equal to V1 by I plus V2 by I plus V3 by I. V by I is R resistance, so V1 by I is R1 and V2 by I is R2 and V3 by R is V3. So this is the formula for calculating the effective resistance in series in a circuit. It is the sum of the resistances added in the circuit. If you take the effective resistances in parallel, the parallel circuit, you will have the three resistances R1, R2 and R3 connected like this with a common voltage. So the current flowing from this battery V will be I, which will get divided as I1 in R1, I2 in R2 and I3 in R3. Now since the current is divided, I can say I is equal to I1 plus I2 plus I3. And since the voltage is common for all the resistances, I divide it by V. I by V is equal to I1 by V plus I2 by V plus I3 by V. I by V is 1 by R. Because V by I is R, I by V will be 1 by R. So I1 by V will be 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 to calculate the effective resistance in parallel. The board exams, they will ask you a question, not directly as series and parallel, can be as a combination of series and parallel, or it can be in an indirect way like this. Say you are given with a wire of 4 ohms. You are circling it. You are making it as a circle, the same wire of length L, and what will be the resistance across A and B? So the wire of length having a resistance R is circled. What is the resistance across its diameter? If this is the question, then you should apply parallel resistance in parallel, because this resistance will get divided into two, because the length will be half on the top and half on the bottom. So 2 ohms on the top and 2 ohms on the bottom. This 4 ohms along its diameter will be 2 ohms on the upside and 2 ohms on the downside. So now 1 by R is equal to 1 by 2 plus 1 by 2, which is equal to 1. So R is equal to 1. So the effective resistance of this 4 ohm wire of length L across, when it is circled along its diameter, will be 1 ohm. Mention unit is very, very important. Ohm is the unit of resistance. You can have some other problems as a combination of resistances in series and parallel. For example, you will be given a circuit like this, and this is applied with the voltage here, and all these resistances are of 4 ohms. Each resistance is 4 ohms. So if they are asking you to find the effective resistance across A and B, you cannot directly do it. You have to think. You have to apply the concept that current at the junction is 0. So the current at the junction here O will be 0, and here you open it like an envelope. You open it like an envelope, it will become like this. You open it like an envelope, across AB, it will be like this. So now you see these two resistances on the top, 4 ohms and 4 ohms, they are in series. The bottom 4 and 4, they are in series. And remaining are all in parallel. So the circuit reduces as this 4 plus 4 is 8 ohms. This 4 ohm will keep as such, and this 4 ohm we will keep as such, and the bottom is 8 ohm. So you have got the equivalent circuit of this. Now all these resistances 8 ohm, 4 ohm, 4 ohm and 8 ohm are in parallel. So I do 1 by R is equal to 1 by 8 plus 1 by 4 plus 1 by 4 plus 1 by 8, which is equal to, you take the LCM 8, this will be 1 plus 2 plus 2 plus 1. So 6 by 8, which is equal to 6 by 8, which is equal to, if you cut it by 2, it will be 3 by 4. So 1 by R is 3 by 4, so you can say R is equal to 4 by 3. 4 by 3. This is how you have to find the equivalent resistance in parallel. After converting it into parallel circuit, this is a combination of series and parallel. So you have to open it in the middle, get an equivalent circuit like this, then find the top part and bottom part of the series, and the middle part as such you keep, so that all the 4 lies in parallel, and finally you get the effective resistance. Now I am giving you another problem. of similar kind where it is not having contact at the center. Say for example, they will give you like this. There's 2 ohms, 2 ohms, 2 ohms, 2 ohms, and this resistance coming, they'll put a jump on this. There will be a hump in the diagram. The hump shows that it is coming without touching it. So this is also 2 ohms and this is also 2 ohms. And you have to find the resistance across A and B. This is another kind of combination of series and parallel. Now you see these 2 ohms and 2 ohms are in series, and these 2 and 2 are in series. They are connected to these 2 ends and these are connected to these 2 ends. The 2 remaining as such. So if you do like that, then this 2 will remain on the top. This 2 and 2 will come here. And this 2 ohms, this 2 ohms and this 2 ohms will come here. And at last we have the remaining 2 ohms here. So now all are in parallel. All of them are in parallel. Now these 2 in the center, 2 ohms and 2 ohms are in series. So you can further simplify it as 2 ohms, 2 plus 2 is 4 ohms, and this is 4 ohms, and this is again 2 ohms. So now all the 4 are in parallel. Now you can put it in parallel. So 1 by R is equal to 1 by 2 plus 1 by 4 plus 1 by 4 plus 1 by 2. So this is equal to, take the LCM, 4, take the LCM as 1 by R is equal to 4. So it will be 2 plus 1 plus 1 plus 2. So 4, 6 by 4, it is 6 by 4, which is 3 by 2. So 1 by R is 3 by 2, so we say R is equal to 2 by 3 ohms. So this is the effective resistance or the collective resistance, and you have to find it like this. Hope you understand. Thank you.